So yesterday we did stuff that had no angles, but today I want to do stuff that does have angles. So here's the situation. I've got this box that weighs, oh man, that was terrible. A box that masses at 3 kilograms. That's its mass. And I want you to find with me the tension in each of those ropes that's holding it up. And you'll notice that those ropes are at different angles. So there's the question. You can copy that into your notes. The question is, what is the tension in each of those ropes? So, this is a force problem. What's the first thing you do when solving a force problem? Draw a picture, yes. And specifically, what type of picture do we want to draw here? Yes, a free body diagram. So I'm going to free that body, which means I'm going to draw the box just by itself. I'm not drawing the ropes here. All I care about is the forces that are acting on that box. Turn to your physics friend and draw the free body diagram. Draw all those forces acting on that box. How many forces are acting on this box? There are 3 acting on the box. Okay. Raise your hand and name one of them, please. Anastasia. Yes, which direction?
Down.
Yes, straight down towards the center of the earth. That's the force of gravity. What's another force acting on this box? Peter.
Force of tension?
Yes. In fact, how many are there?
2.
2. So there's one off in this direction, and there's one kind of in this direction. I'm going to label this T1 and this one T2. They are forces. I just didn't put the F there. It'd be less confusing if we do it that way. So just remember that the T's are 2 different forces. Okay, so you drew a free body diagram. The next thing you do is you write down the sum of the forces. And we always look at the sum of the forces in 2 directions. So I've got sum of the forces in the x direction, and that equals ma. F always equals ma. And you'll write this step identical to this every single time you do a force problem. That's every problem this week and every problem next week. By the way, I'm thinking of having a quiz on Tuesday. Why did I say Tuesday? I'm thinking of having a quiz on Friday.
This Friday?
This Friday.
Oh.
Why is that a problem?
Oh, we were Tuesday.
No, I don't know why I said Tuesday. We are doing a we are doing a quiz on Friday. All multiple choice. It's on forces. Free body diagrams and stuff like that. I don't know, I'll say no. This step is the same on every single free body diagram. So you start with the free body diagram, next step in the force problem is always that step. Now we have to ask ourselves, what is the acceleration? So, in the x direction, that's this way, is it a speeder or an accelerator? It's a speeder. In fact, what is its speed? 0, yeah. So because it's a speeder, the acceleration is 0. What about in the y direction? Vertically speaking, is it a speeder or an accelerator? Speeder. How do you know that? Yeah, it's not moving at all. So its acceleration is 0. It is a speeder. Now, just to simplify things a little bit, I'm going to write that. And same thing there. Again, first step, free body diagram. Second step, F equals ma. Third step is what we're doing right now. You gotta tell me, what are these forces? So first of all, look at your picture. How many X forces are there? Talk about with your physics friend. How many X forces are there? 2, yes, but where are they? This is not the X direction, that's not the X direction. Yes, they are vectors, so I can break this up into components. There's T2 in the X direction. Here's T1 in the X direction. And of course there are vertical forces then, just like that. T2y and T1y. So, since there are 2 X forces, I'm going to write them right here. I'm telling you in this step, the sum of the forces equals 0. Now you have to tell me what forces you're adding up. I've got T2x, and should I add or subtract the T1x? Subtract, but I thought sum meant add. It's very good. I'm adding negative, so I'm going to put that in there. I took care of direction right then. Turn to your physics friend and see if you can figure out the next line for the y stuff. Go.
It's going good.
What was it? T2x and T2 or T1x. So that's a force going.
How many y forces are there? 3. How many ups?
2.
Yes, so I need T1y plus T2y minus force of gravity equals 0. Again, why did I do minus force of gravity? It's going down. Good. Now at this point, the physics is done. If you have your free body diagram correct, which I hope, if you get this wrong, then the whole problem's going to be wrong for sure. So make sure you get this right. But if this is right, you did some physics for that. You did some physics here and here and here, but now it's all math. I know you can all do algebra and trig. So if you get this far, then you've done the physics. But here's where the math comes in. If you look at this, we've got 2 equations. We have 5 unknowns. That's not voting very well for us. We know the angles. That's true. In fact, maybe I should write those up here. This is 45 degrees. This is 60 degrees. I have to include the angles somewhere up there, somehow. Colin. Force of gravity I can probably figure out because I know the mass. I know the acceleration due to gravity. In fact, why don't we just do that? That's the easy one. Let's pick the low-hanging fruit. How do you find force of gravity? How do you find the force on anything? What is the equation for force? F equals ma. This is still a force, so F still equals ma for this. So I can put the mass in. 3 kilograms. But what do you use for A? I thought A was 0.
Oh, say that louder.
Yeah, be careful here. This is the overall acceleration. Here I'm asking you, what is the acceleration due to gravity? What is the acceleration due to gravity? Yeah, 9.8. Good. Now, why did I not put negative 9.8? Sarah? Yes, I already took care of the direction up here. In fact, this is one of the beauties of when you do things with forces here. Once I get this equation right, if I have the directions right and everything, I don't have to think about direction the rest of the way. I'll just plug in the numbers like 9.8. The direction's already taken care of, so I don't want to put in a negative. Okay, that's solved for this. What is 3 times 9.8? 29.4? Okay. That's good, we just made progress. We went from 2 equations and 5 unknowns to 2 equations and 4 unknowns. Still not solvable in its present state. But we're making progress. Now Annika says something about these angles have to be included, but I've got nothing but a 45 and 60 over here. Any ideas on how we should do that? Courtney?
So you do like, right, what you do like, the cosine of so you do,
You got it, that's the idea, yeah. Use some trig somewhere. Right, if I go back to this, and let's see, I'll write this down here. If I'm looking at this triangle alone, I could set something up like this. The sine of 45 degrees. Now what would the sine be of 45 degrees? What over what? Opposite of hypotenuse. What's the opposite here? T2y over T2. Now how does that help us? Well, let's take a look over here. I have a T2y there. Maybe I can substitute something in here like this. T1y plus T2 sine of 45. Once you write that down, I want you to turn to your physics friend, and I want you to show them how I went from this in black to this in blue. Go.
So then you get these fusions divided by equals
Because I mean, if I'm trying to find
Okay, while you're with your physics friend, figure this out. What would you do for T1y? What would that look like? Talk about it with your physics friend. Go.
No, it's T2 sine 45. Yeah. You just took this and made it, so then it's 2ty equals that.
Alright, if you look on the board, it should look something like this. Instead of T1y, I did T1 sine of 60, the exact same type of method I used over here. Now how about for this stuff? What would you use in the x? What trig function would you use to find the x components? You use cosine, yeah. So if I go over here and do cosine of 60 degrees equals adjacent T1x over, hypotenuse T1. And in the same way I can say T1x then must be T1 times cosine of 60. Now in your notes, I want you to try this on your own. Fill in these two spots. I just gave you one of them, it's T1 cosine 60. Fill in these two spots. See if you can do that. And then once you've tried it, see if you got it right. Check with your physics friend. Should look like this, what I have on the board. Now, why did we do all of that? First of all, Annika said that we should, so you can blame her. Secondly, she's right on here, this really helped us. We still have two equations, but how many unknowns do we have between those two equations? Just two. If I have two equations and two unknowns, that means you can solve it. Now at this point you can do system of equations because some people like to do systems of equations. For those of you that don't know what that means, I'm going to show you a different way to do it. This is what I would do. First of all, I'd simplify this a little bit and move the cosine 60 to the other side. Like that. And then you need to remember that cosine 45 and cosine 60, those are just numbers. That's all this is. So I could solve this and say T2 is equal to T1 cosine 60 divided by cosine 45. And you can plug that into your calculator and get a number. Cosine 60 divided by cosine 45. Find out what it is. Make sure your calculator is in degree mode when you do. Anybody get it yet? Cosine 45, I'm sorry, cosine 60 divided by cosine 45? 0.707? That's good. That's pretty good. We've reduced this down to a pretty simple equation. What do you do with that though? You still have two unknowns in that. Exact superior student, yes. Right, you just solve for T2. It's the same T2 that's over here, so you can plug that into that spot. And then you just have a little bit of algebra. Just see if you can solve that now. One variable. That's it. Down to one variable. You can solve that using algebra.
Couldn't quite figure out how to just tip it down, so I'm just holding it there.